Imagine looking up at the night sky and, knowing your own experiment is just orbiting Earth at like 17,000 miles an hour.
It's wild to think about.
Right. I mean, for decades, space was basically this gated community for billionaires,
Yeah.
test pilots, and scientists with these long strings of letters after their names.
Yeah, the VIPs.
Exactly.
Yeah.
But today, well, the bouncers basically left the building. So welcome to this deep dive. We are looking at this really fascinating collection of notes and excerpts from a project called GULS 9000, Democratizing the Final Frontier.
Such a good collection.
It really is. And our mission for you today is to understand exactly how space exploration has shifted from being this, exclusive club into a totally vibrant, accessible field for everyday people.
Yeah, and setting the scene here, the central theme of this GLS 9000 material is really the rise of citizen science in space.
Right.
And, we are not talking about just passively watching a live stream of a rocket launch on your phone.
No.
We're talking about actual, rigorous scientific contribution. For the longest time, the narrative was just that without institutional backing or advanced degrees, you couldn't even look at raw space data.
Like it was classified or something.
Right, exactly. But the sources we're examining, they present this massive paradigm shift. The primary requirement for entry is no longer a NASA badge or a specific credential. It's really just sheer curiosity.
Okay, let's unpack this because the traditional space exploration model is like, it's like an exclusive, walled-off VIP club, right?
Yeah, very much so.
But this new era of citizen science has effectively blown the doors off the hinges, just inviting everyone inside. And the sources really bring the receipts on this.
Oh, they definitely do.
They highlight these incredibly grounded examples that completely shatter that traditional astronaut stereotype. I mean, we are reading about a nurse in Tromsø,
Right.
a fisherman making his living out of Bergen, a teacher running a classroom in Stockholm.
Just everyday people.
Exactly. It immediately makes you wonder how people in these highly demanding, earthbound professions are actually contributing to real space science.
Well, what's fascinating here is that the barriers to entry have just completely vanished. To understand how a fisherman or a nurse crosses that threshold, we actually have to look at a precedent set from the inside up in orbit.
Okay, what do you mean?
So the JUL's 9000 notes point specifically to NASA astronaut Don Pettit.
Oh, right, the ISS guy.
Yeah, he is essentially the ultimate proof of concept for everyday experimentation. When Pettit was stationed on the ISS, he didn't just run the, multi-million-dollar pre-planned payload.
Right, he had his own side projects.
Exactly. He used his free time to conduct what he called Saturday morning science.
Which I love. But, push back here for a second. It's one thing to say a fisherman can contribute, but how are they actually getting their ideas up into orbit without a billion-dollar rocket? Or, wait, let me back up. With Pettit, he was using everyday items.
Right, literally things lying around the station.
Yeah. But how does that actually yield rigorous data? Because when I think of orbital mechanics or fluid dynamics, I assume you need, custom-built sensors, not something you'd find in a supply closet.
And that's the beauty of it. Pettit took a completely ordinary Teflon knitting needle.
Wait, a knitting needle in space?
Yeah, he rubbed it to create a static electrical charge, and then he used a syringe to squirt these tiny water droplets near it.
Oh, wow.
And in microgravity, without the overpowering force of Earth's gravity just pulling the water down, electrostatic forces suddenly take over completely.
Oh, I see.
So those water droplets began to orbit the charged knitting needle exactly like planets orbiting a star.
That is brilliant. So he basically built a working model of a solar system using static electricity and like a knitting needle.
Exactly. And in doing so, he demonstrated complex electrostatic forces, orbital dynamics, resonance without a 10-year engineering cycle. This is what the sources call the Pettit effect. He validated the core philosophy of citizen science by proving that non-professional researchers, or anyone really, can conduct meaningful microgravity experiments. You don't need a massive apparatus.
So Pettit proves that the scientific method works beautifully with simple tools. But, okay, coming back to my earlier point, Pettit was already living on the space station.
You're right, if he had the access.
Exactly. A fisherman in Bergen obviously isn't on the ISS, so it's one thing to say a fisherman has a great idea, but how are they actually getting their ideas up into orbit without a billion-dollar rocket? You can't just slap a stamp on a water droplet experiment and mail it to low Earth orbit.
No, you definitely can't. And that is the exact logistical wall that a new wave of platforms is actively trying to break down right now.
Okay, so who's doing this?
The sources focus heavily on an organization called SERA.
SERA.
Right. It's a platform specifically engineered to handle that massive logistical wall. And the scale of the crowd power here is just staggering.
How big are we talking?
Well, as of the data in these notes, there are over 140,000 ordinary citizens actively participating in the space race through SERA.
Wait, 140,000. But isn't there a huge risk there? Like if you open the floodgates and crowdsource space science to that many random people, don't you just end up with a massive pile of junk data?
You would think so, yeah.
I mean, surely real scientists have to waste thousands of hours sifting through terrible proposals just to find one that actually works.
Well, that assumes the public lacks specialized knowledge, which isn't the case. SERA mitigates that junk data problem by running highly structured initiatives, like their Fluid Dynamics Challenge.
Oh, okay, so it's guided.
Exactly. They give the crowd a specific framework and specific physical constraints. Absolutely anyone can submit a real microgravity experiment within those constraints, and then the platform handles all the hard stuff, the rocketry, the agency negotiations, the launch.
And here's where it gets really interesting in the source notes.
Yeah.
The person who submitted this highly complex, viable microgravity experiment wasn't some academic in a lab.
No, not at all.
It was an offshore rig worker from Bergen. Like, that was their first microgravity experiment. And even wilder, someone from Norway is currently ranked #1 out of that entire 140,000-person SERA participant pool.
It's incredible.
But how does an offshore worker out-innovate an aerospace engineer on fluid dynamics?
Because if we connect this to the bigger picture, an offshore rig worker deals with chaotic fluid dynamics every single day of their life, way more than an academic in a clean room does.
Oh, that makes total sense.
Think about an oil rig. You have oil, water, gas, and sediment mixing under extreme pressure in like miles of piping. It is highly unpredictable.
Right, it's messy.
Very messy. So that worker has an intuitive, hands-on understanding of how those fluids behave and react to stress. And when you have 140,000 diverse minds working on these problems, it completely dwarfs the research capacity of a traditional, isolated space agency lab.
Especially because when you take away Earth's gravity, fluid behavior gets even more chaotic.
Yeah. Precisely. Surface tension and capillary action just completely take over. Liquids crawl up the walls. They choke up mechanical systems.
Wow.
So the offshore workers' practical knowledge gave them a unique angle. It really shows what happens when ordinary people start believing space is for them.
Let's talk about the geography of this for a second, because there is a glaring pattern in the JOLES 9000 data.
Yeah, the location.
Right. Since the Tromsø nurse, the Bergen fisherman, the Bergen offshore worker, and that #1 SERA rank are all connected to Norway. Why is this specific Scandinavian region punching so far above its weight?
So Norway is uniquely positioned to lead citizen space science in Scandinavia.
Yeah.
And a lot of this is due to its strategic roles within European space exploration.
Like top-down infrastructure.
Right. They're deeply embedded in the European Space Agency, the ESA. But more importantly, they host MoonDAO Space.
MoonDAO Space, that's a launch facility, right?
Yeah, it's a massive launch facility and research center physically located in Norway. When you see launches happening from your own soil, space stops feeling like this abstract concept and starts feeling local.
But it's not just top-down institutional support, right? Because the notes point out that there is a serious grassroots movement happening there, too.
Oh, absolutely.
Like there's that bit in the source material about a citizen who started Western Norway's very first CE5 contact group.
Right, the CE5 group.
Which, just for context, is about human-initiated contact with extraterrestrials. So instead of waiting for a government telescope to passively listen, everyday people are organizing themselves and actively trying to initiate contact. It proves the public's engagement is happening on these multiple, highly personal levels.
Exactly. Whether you are modeling fluid dynamics for a SERA payload or searching the night sky for anomalies with a community group, the underlying premise is identical. You are not waiting for permission to interact with the cosmos.
Okay, but if everyday people from places like Norway are now building the experiments and initiating contact, who gets to decide who actually goes to space? And who makes the rules once we get there?
Ah, the governance question.
Right, because the old bouncer checky credentials at the door is gone.
That is the most complex hurdle here. The notes introduce a wave of organizations dedicated to these exact questions. You have Space for Humanity, Celestial Commons, and MoonDAO.
Let's break those down. Space for Humanity first.
Yeah.
Because they operate on the core belief that everyone deserves to go to space, right? It's not just about tourists.
Far from it. Space for Humanity is focused on the democratization of the overview effect, that profound psychological shift astronauts get when they see the Earth from orbit.
Right, seeing it without borders.
Exactly. They push for physical inclusion by sponsoring flights for everyday leaders, teachers, artists, so they can bring that paradigm-shifting perspective back to their local communities.
Which leads right into celestial commons. The notes suggest they're focused on why democratic space governance matters. Why is that an issue? Don't we have international laws?
We do, like the 1967 Outer Space Treaty,
Right.
but it's incredibly outdated. It was written before private, multi-billion-dollar corporations had the capability to, say, mine asteroids.
Oh, so there are loopholes.
Huge loopholes. Celestial Commons is fighting to ensure we don't default to an oligarchy where the first corporation to land a drill makes all the rules. They treat orbital space as a global commons.
So what does this all mean when we bring in the third group, MoonDAO? How exactly does blockchain meet space exploration? Is this about decentralizing the power away from the mega corporations?
This raises an important question about the future of authority off-world. A DAO is a decentralized autonomous organization. It's essentially a community where governance rules are encoded on a public blockchain.
Okay.
Anyone holding a token has a vote. They pool real capital into a treasury, propose a project like funding a zero-gravity 3D printer, and vote on it.
Wow, so there's no CEO to veto it.
Exactly. If it passes, the smart contract automatically releases the funds. So if we synthesize these three groups, MoonDAO democratizes access via blockchain, Celestial Commons pushes for democratic governance, and Space for Humanity pushes for physical inclusion.
Right.
Together, they represent this unified front, ensuring space doesn't remain the property of governments or billionaires.
It's an entire parallel space agency
Yeah.
built from the ground up.
Yeah.
When you look at the incredible journey we've just taken on this deep dive, I mean, we went from NASA's Don Pettit proving citizen science works with a knitting needle on the ISS
Yeah.
to an offshore worker in Bergen designing fluid dynamics experiments,
Yeah.
all the way to MoonDAO using blockchain to democratize the stars.
It's moving so fast.
It really is.
Yeah.
And the core message of these Jolie 9000 notes is unmistakable. You don't need to be an astronaut. The barrier to entry has evaporated. The next person to contribute to space science might literally be you, the person listening right now.
And that leaves us with a final thought to mull over. If decentralized platforms like MoonDAO and these massive 140,000-person networks like SERA begin to out-innovate traditional government space agencies,
Oh, that's a wild thought.
will the first true laws of human off-world settlements be written on a public blockchain by everyday citizen scientists rather than by Earth-based politicians?
Wow. If the town hall builds the settlement, the town hall makes the rules, right? We'll have to see if the public can keep those doors blown wide open. Keep that in mind the next time you look up at the night sky. Stay curious, stay grounded, and keep looking up. We'll catch you on the next Deep Dive.